Well, welcome to Coffee with TMEs. I'm Jeff McLaughlin, TME Director at Cisco, and I have with me today Pradeep Saran. Hello, Pradeep.
Hey, Jeff. Good morning. How are you doing?
I'm doing well. Good evening to you. So we're going to be talking today about rogue detection and aWIPS in Cisco DNA Center. But before we get started, why don't you give the audience a background on yourself and how you got to be a TME?
Absolutely, yeah. Thanks for having me on your podcast, Jeff. So I started my career in content delivery networks. So it was a startup. It was started by a bunch of friends. So we started on content delivery networks good 12 years before. That's when AWS was getting started. So we had a lot of softwares, tools on top of that. And then I got into wireless, right? A lot of exciting things were getting started then. Especially in the Valley. So I got into a single channel architecture. That was another startup in the Valley. And then got into Cisco. So I've been here for good 6 years. I spent a good amount of time on ICE and got into DNA Center. So currently I'm in TME role. So currently thoroughly enjoying the whole role itself. Yeah.
That's great. Well, content delivery is kind of a different path than a lot of network engineers I've seen. You know, they started with hardcore routing or that sort of thing. So that's great. Was there a connection between content delivery and wireless, or did you just take a totally different direction?
So there was not much of a connection. So, but in the startup world, you get to do everything, right? So that's where gave me a good route to get into wireless. That's
great. And did you bring a cup of coffee? I know it's late there. Maybe you're...
Yeah, absolutely. Yeah, coffee anytime. Yes.
All right, that's good. It's early here, so I need it, and it's late for you, so you need it to stay up. So,
yeah, I have a couple of meetings as well, so it's good to have one now.
Still, all right. Well, when I think about this, so we're talking about rogue and aWIPS. And, I'm not a wireless guy, Pradeep, it's not my expertise, but I know something about it. And I've certainly worked on intrusion prevention systems in the past. In fact, when I did my CCIE security in 2008, we made a IPS appliance. And I remember it being sort of a signature-based system for detecting, bad devices on the network, whether they have malware or that sort of thing. It was very signature-based, I remember, and you had to update the signatures from time to time to make sure that you were on top of the latest malware. And I remember as wireless was first coming out, even in the early days, there was a lot of talk about rogue. What if somebody brings an AP from home and sets it up and, not even necessarily maliciously, but just brings their own stuff and starts operating their own network, or what if somebody malicious tries to, take over your SSID or broadcast your SSID and get users to connect to it and somehow compromise your network? So I know that's been a concern from the beginning, and I know we've had tools to deal with those things from the beginning. So I guess my question is, what's different now? We have obviously Cisco DNA Center involved, but how is this different from what we've done in the past?
Very, very good question. Yeah. So what we are doing currently is the threats obviously has become more intelligent nowadays. So there are a whole lot of tools that people create, and they want to take over the RF. They want to bring down your network, bring down your performance, and a lot of new threats have come in, right? So that is one way to look at it. And the second part is we are adding a lot of intelligence on DNA Center to identify those threats. And most important part is not only identifying it, we have ways to contain those threats. That is more important nowadays. And to that, we are also adding location to that, right? So when somebody is getting attacked, not only we tell that who is getting attacked and the location of the threat, which plays a very important role today, because if you want to contain it, obviously you can use the software-based containment. Or if you want to physically remove that rogue access point, you can use the location services. So today on DNA Center, we have integration with DNA Spaces and CMX, so where we provide the live location of the threat. So that is very important in terms of containment, apart from the software containment that we have. And we are doing a whole lot of other things on DNA Center, right? So if you look at it, we are getting streaming telemetry from multiple different controllers. That's where we are bringing in the value. We are bringing in the single pane of glass approach, where we get these threats from multiple controllers, and we are doing a lot of analytics on top of that, right?
I see. So when we look at rogue detection, again, thinking back to the early days, I remember a lot of what we talked about was, if somebody brings one of these rogue devices on your network, just cranking up the signal on the surrounding APs and maybe trying to drown it out. But what you're saying, so there's first of all a different approach now from what I remember, right? But second of all, you can even use DNA spaces and so forth to actually locate where that device is, so you can physically go and find it.
Yes. So basically, we use the RSSI. So based on the so let's say your AP is getting attacked, and based on that RSSI signal must be heard by 5 different APs, right? So based on the AP with the strongest signal strength, we provide you the precise location of the threat. So that's how we are able to do all the triangulation, whole lot of logic on top of that, and then able to provide you pinpointed location of the threat.
So then you can go and physically remove the threat at that point.
Absolutely, yeah. But because today, this containment that we do, right? Once you do the containment from DNA Center, what we do is we basically broadcast the de-authentication frames, so that nobody connects to that access point anymore. But again, you can't do that forever, right? Because even the AP which if you constantly bombard the de-authentication frames, so again, it will probably bring in more damage to your RF. So to get started with, you can do the containment and physically locate the threat and then remove it forever, right? So that's the direction, yeah.
So how do the de-authentication frames work? So first of all, you said they come from DNA Center itself.
Yes.
And so if I'm a client and I've accidentally connected to this rogue AP, which has the same SSID, say, as our corporate SSID, so DNA Center talks to the wireless controller, and that's how the de-authentication frames get sent.
Absolutely.
What are the mechanics of that?
Great question. Yeah. So what we do today is we brought in the whole intelligence on the access points, right? So first is signature-based threats like your DOS attacks or your flood attacks, right? So if somebody's flooding your network with de-authentication frames, so the APs are designed to listen to those threats and then immediately inform DNA Center that I'm seeing a flood of de-authentication frames and this seems to be a threat, right? So immediately DNA Center, on DNA Center, you will see a notification saying that there is a de-authentication flood happening on your network. And then once you click on that, it will give you all the details as to who the vendor is, where the location of the threat is, all those details. Now coming to the rogue, for example, you gave an example of honeypot, somebody broadcasting your own SSID, right? On their hotspot, or be it any device or anything, right? Be it a ad hoc, a peer-to-peer communication that's happening. So what really happens is AP will listen to those threats, send it to DNA Center. On DNA Center, we have a classification engine where we have multiple algorithms which will run. It will identify the threat and then show it on DNA Center. So from DNA Center, you can hit a containment. So in turn, from DNA Center, it goes to the AP. AP will send the de-authentication frames so that nobody else will connect to those rogue access points which are broadcasting your same SSID.
Well, there's a lot more that you can do than back when I was first looking at wireless, Pradeep, so very interesting. I wanted to point out another thing that you mentioned, which was the single pane of glass thing, because I guess the question is, a lot of this can be done by the controller, right? Like you don't necessarily need DNA Center, and so what advantage does it provide? And one thing you said, you could have multiple controllers across your network, but if you have them all onboarded into DNAC, then DNAC can detect and respond across multiple controllers. Is that the idea?
Absolutely, absolutely, yes. So today we support both AirOS as well as 9800 controllers. So let's say example of a network has good 10 controllers. You add all your 10 controllers to DNA Center. We receive the streaming telemetry, which is an encrypted channel where we get all the events from all different controllers. We collect that, and then the intelligence will be applied on top of that, right? So we add more intelligence on top of the threats that we are receiving. That's where the whole classification engine comes into play. And then we classify the threats based on the priority. So, and after we classify, it comes as high threats, informational threats and things like that. That's how we classify the threats. And coming to what is the value that DNA Center actually provides. First and foremost, one is obviously the single pane of glass approach, and the second one is the forensic captures. So today we have gone even little beyond than what the traditional Rogue and aWIPS solution does. When a threat occurs, we can even capture the packets of air and then send it to DNA Center. So that's the intelligence that we are able to bring in today. So how we are able to do that? We create a gRPC tunnel directly from the access point to DNA Center. We bypass the controller, we create a tunnel, encrypted tunnel. As in when AP sees a threat, it will capture the packets of air and then send it directly to DNA Center. So what basically the administrator gets is the threat information. Along with that, he gets a live packet capture. He gets a forensic capture, which basically can use, the SecOps team can use for their further investigation or to understand how the threat pattern is. That plays a very important role these days, right? So they can use it for audit. There are a whole lot of other things which customers will do. The SecOps team, it goes through different analysis, and then they will want to have it for audit purposes as well.
So
and
this
obviously
would be like
location also.
Sorry, this would be like a PCAP file that you could open
Absolutely.
in Wireshark or something.
Correct.
So one thing you mentioned, Pradeep, was streaming telemetry. And now is that going from the controller to DNAC or from the AP to DNAC?
Good question. Yeah, absolutely. So what we do is, so we create a telemetry channel. It is nothing but a TLS encrypted tunnel that goes between the controllers and the DNA Center. So there are a bunch of things, we call it channels, the bunch of channels that gets created for each and every feature that you enable it on DNA Center. As and when you do that, we look for rogue clients, we look for aWIPS, and other channels basically will get enabled on the controllers which are basically added to DNA Center. So we create the tunnel, we subscribe to those channels for us to receive those real-time threats from controllers.
I see, and this telemetry works with both AirOS and the 9800. Okay, and it's TLS based, you said. And by streaming, you mean it's not like, I know there's a lot of talk about it.
Or not like SNMP traps or things like that. It's a streaming real time. Yes.
Okay, that's great. Now, you know, I'm a programmability guy. I have a background in that. Even though I'm an old school network engineer, I do like playing around with Python and all of that. And so it's important for me to be able to access this kind of information through APIs as well. So I know we've got APIs on DNAC. So do we have the ability to access the Rogue and aWIPS data through APIs?
Absolutely. Very good question, Jeff. So there are a lot of customers. Lately, I've worked with a lot of big customers where they want to consume the northbound APIs and then create their own dashboards, right? Because wireless threats play a very, very important role in today's network. So what they basically do is they have a SecOps kind of a team which basically monitors this 24/7. So they create their own NOC dashboards for this, and then they display it on the big screens. So as and when threat comes into the picture, they have a cycle how they want to contain this, right? So how they want to investigate this further, and then they have their own process to go through that. So what we do is we have exposed the northbound APIs from DNA Center. So where they can subscribe to these APIs, and we send the alerts. And then I've seen customers consuming it on Splunk, where they create their own dashboards. And we also have capability to do webhook notifications. That is a in thing now. So a lot of customers ask for it. So as and when threat occurs, we send a webhook notification. They can subscribe to that webhook notification and then use tools like ServiceNow, where the ticket generates. That is something which the users can do. Or we also have reporting capability, right? So you can basically generate or schedule daily reports or weekly reports. So where not only we send an email notification out daily, or we send in the form of the JSON, right? They can consume the JSON and then do more analytics on top of that.
So I think one important point here is even if we had all these capabilities in the WLCs, if you were writing a script or using a custom dashboard or that sort of thing, without DNA Center, you'd have to go to each controller individually to get this information. And I think something people don't think about. I mean, when you look at excuse me, APIs. A lot of this is information you could get from DNA Center, just from the GUI, right? You could go to the correct screen and find it. But DNA Center can also act as an aggregation point so that you have a single place where you're querying. And if you have to write, a script, or if you're building one of these custom dashboards, it's kind of a hassle to have to go name all of these different devices you want to query from. So you actually end up with this central aggregation point if you use DNA Center.
Absolutely, yeah. And the other thing that we are also working in the backend is we are trying to provide the impact analysis. Let's say you're under attack. You want to understand how big that attack is, how many users are getting attacked, or how many users are getting into trouble, right? So if somebody is doing a deauthentication flood, so it could be that not only the access point which is closer to that threat will get affected, even the nearby access points. There could be hundreds and hundreds of users who are connected to those APs can also get impacted because of this. So what we are also working in the backend is to provide that visibility as to how many users are actually getting impacted because of this threat, so that we are basically providing more value on top of what we are currently showing. So that's the other direction which we are getting into, where you can only do this because DNA Center knows all the clients, and we have the health scores and a whole lot of other things on top of the actual network itself.
And that's a very important point with intrusion prevention. I remember a long time ago when I was running my own network, and I had a Snort open source IPS set up, and I think this is back in the day when everybody was still wired, so it tells you it was a long time ago. But one of the hard things about dealing with that IPS, I'd go log in, I'd look at it in the morning, and there was a lot of noise, right? There were all these alerts, and you wanted to know, is this significant? Is this something I should worry about, or is this just noise, some minor thing? So I hadn't actually thought about what you're describing, which is, not only giving you the data, here's what's happening, but telling you actually how important it is and what the impact is. And it was funny, I actually knew I had a major event when that sensor would crash and I couldn't log in. I'm like, okay, I know that's my impact analysis right there. The thing crashed, so I know it's high impact because it couldn't keep up with the volume of alerts. One other thing I wanted to mention too, just for the benefit of listeners, is I know not everybody's a programmability expert, but you had mentioned webhooks, and for the benefit of the listeners, the idea there is, I could write, say, a script that queries the APIs on DNA Center, but I actually have to go run that query from the script myself. Either it has to poll it periodically, or I have to just periodically run that. Or if we had a reporting tool like a dashboard, it's going to have to periodically go poll. Whereas webhooks is a push model. So if an event comes up in DNA Center, it can actually push to that consuming client, right? So I just wanted to mention that, because sometimes I know network engineers are always a bit reluctant to get into the programmability stuff. It's not that hard, but just a reminder for them. So let's see, I know you had a demo, Pradeep. Is there anything else you wanted to talk
Yes.
about before the demo, or do you want to go into that?
Let's dive into the demo then. Yeah, sure.
Perfect.
I'll quickly showcase some of the capabilities on DNA Center. Okay, great. So this is the DNA Center dashboard here. So let's get into the Rogue and aWIPS. So if you see here, this is the dashboard that we have where we showcase all the threads. And this is the on-off button to enable, disable Rogue and aWIPS. And the most important part is we also have time travel. So you can go back in time for the last 14 days and then even look up your threads. So we save all that information on DNA Center. So let's say you have 10 to 20 controllers. Each controller is bombarding a lot of threads. We save all those threads. We do analytics correlations on top of that. And the best part is we store that information for you to even look up after 14 days and then see what is actually happening on your network, right? So, and this is the threat dashboard. We give you very clear visibility as to what are the high threats on your network. So you can see the deauthentication broadcast, association flood, whole lot of threats that's basically on your network. And on to your right, we also have the high threats over the time. This basically tells you what is the pattern, how many threats are happening over time. So that's the intent behind this graph. And this is the meat of the whole solution, right? So if you, this is the threat table where we provide what is the level of your threat and what is the threat MAC address, what is the type of threat, and then a whole lot of other things that we provide, what is the RSSI and what is the SSID which is getting attacked and things like that. So that's the intent behind having this, the threat table. So let's get into one of the threats here. So my favorite, Rogue on Wire. So if you look at this guy, so this is nothing but a pretty straightforward threat, but it's very impactful one. So if you look at it, so this is nothing but a rogue on wire, as the name says. Somebody connects a rogue access point onto your switching network. So what we are doing is we are doing a lot of intelligent things here. So we are gone away from RLDP, which is basically the legacy protocol which is used to detect the rogue on wire threats. What we do today is, since we have DNA Center, which has the list of all the switches which is on your network, we do switch port tracing mechanism, right? So we basically compare the BSSID and we take the Ethernet MAC address of your rogue AP. We do correlation. We have multi-vendor algorithms. So we have close to 10 vendors where we've written multi-vendor algorithms. We compare that and then look up the host table on DNA Center. So that's how we do correlation and then identify the rogue on wire. And we immediately raise an alert saying that there is a rogue on wire, and we give you the vendor information and all the details are basically provided. So all the vendor details, when it's reported, the location of the threat is also provided. And the most important part is we provide you the switch port detail as to which switch it is connected to, which interface it's connected to, right? All those details are provided, and this is nothing but the AP which is detecting that. And if there are any rogue clients connected, we give you that. And now coming to the important part, we also do the containment. So where we from DNA Center, you can even shut down the switch port. So that's where all the intelligence comes into play, right? Because DNA Center has the complete repository of your switches. So we are using DNA Center and then sending a request to the switch to shut down that switch port. Because we have all the details, we can directly go ahead and contain that from DNA Center. So that's the direction that we have taken in terms of the rogue on wire. Let's take a look at one more threat. Pretty much see honeypot, right? So this is again a common threat where somebody is broadcasting a same SSID as your production SSID, and we give you the live location using DNA Spaces, CMX integration, and we provide you all the details. And here is the containment, right? So when you click on containment, automatically the request is sent to the AP from DNA Center. The AP starts sending the deauthentication frames. And Jeff, one more point I would like to stress upon here is, with our latest Catalyst access points, we have RF ASIC. So we have a really upper hand here in terms of rogue containment and detection. So this is as good as having your AP in the monitor mode, right? So a lot of customers basically they have a separate access point for monitoring the threats. So you no longer have to do that. With these latest APs, especially the RFA-SIC, all the rogue containment and detection will happen using the special RFA-SIC that we have on the latest APs. So you no longer have to put your APs in the monitor mode, and then it won't even impact the client servicing as well. That's the intention behind that feature. And once you do hit containment, automatically we bombard using the RFA-SIC. And now let's take a look at some of the newer features, something like allowed list. So we recently brought in allowed list, where if you have your neighbor access points, right? So you can basically add your neighbor access points to that list, and then so that they no longer will come up as your threats. So that's the intention behind your allowed list. Now, another interesting feature that we came up is aWIPS profile. So if you see here, so we have all these signatures that we support today. So the good thing is you can even configure the thresholds. So when you configure these thresholds, what DNA Center does is once you save these thresholds are sent back to the access points. So the access points will start listening in a different configured threshold. And onto your right, you also have an option to enable, disable the forensic captures. So you can enable, disable the forensic captures for the WIPS signature that you want. And then as and when the threat occurs, we take the forensic captures and send it directly to DNA Center. So that's the direction. Let me see if I can show one of the forensic captures here on my setup. So yeah, if you see here, this is how it look like. So basically we send the forensic captures directly from DNA Center or the access point to the DNA Center. So this is how the PCAP file will look like. You can download and then start your SecOps or audit process on top of that.
All right, Pradeep. So thank you very much. I think that was a great demo, and yeah, I think that was a good point about the RFA-SIC too, which I hadn't thought about. So not only does DNA Center help you with this, but the APs themselves are engineered in such a way that it's a lot easier to take advantage of these features, right?
Absolutely.
Well, thanks, Pradeep. This was really informative, and especially for somebody who's not a wireless guy, I did learn a lot today, and I know that's where so many of our threats come from, obviously, because wireless is not contained the way a wired network is. So you really have to be on top of this, and I can see how DNA Center really helps with that. So, Pradeep, thank you very much for taking this time with me today, this morning or your evening. Really appreciate it, and it was great and informative, and I look forward to working with Rogue and aWIPS myself now that I know how they work.
Great, Jeff. Yeah, thank you very much for having me on your show. Yeah, thank you. Take care.
Thanks, Pradeep.